Yeah, last class we have through completed Modulo-5. A quick brief what we're talking about it of the spread spectrum communication system. What is exactly spread spectrum? Basically, there are two factors absolutely left with digital communication, any kind of course, even in any kind of a communication system, utilize and bandwidth efficiently. Second is absolutely using as lesser power of this. So for this matter, this is a two-factor. Absolutely, the successful communication engineer will trade up a factor, either bandwidth or a transmitted power. In order to give the trade-off factor, there is a one factor defined called as DE, that is bandwidth expansion factor. Look like what exactly the bandwidth expansion factor is W by R. W is equal to width of the channel, R is equal to transmitted power, transmitted rate. Okay, so absolutely transmitted information rate at the bit. Look back, very important. W is absolutely channel width, R is equal to information width. Number of information is more per cycle, high data rate. Okay, that means less power. For example, let me say we have a 24 bits. 24, each bit will take some power to transmit. Instead of 24 bit, sending each bit of the 24 sending alone, rather than that, if you use 3 bit at a together transmit, absolutely same power of the single bit can be utilized for transmitting the 3 bits, which is exactly called as what we are saving, that we are saving the transmission power. That means this what you absolute this R, okay, this R will really help you to reduce the transmit power. This will look back here, absolute. If you want to reduce the transmission power, so you should use the channel bandwidth as much as possible, so that what will transmitted power will be less. That means if you increase the, so if you want to increase a transmit rate, but rate, okay, this is higher, okay, this become less. That means transmitted rate is high, okay, transmit power is also high, and bandwidth expansion is less, okay, because bandwidth is inversely proportional one way. If the width of the channel is high, and bandwidth expansion factor is this. For example, let us take, generally you wanted to reduce the transmitted power, okay, generally you wanted to transmit the power, okay, exactly, transmit the transmit power as less as possible. We increase the width of the signal, which is passing through the channel, which has a bandwidth weight. That means transmitted single bandwidth should be equal to the bandwidth of the channel. Then automatically what will happen, this R will be less as per this equation, bandwidth expansion is high. So when R is less, that is information rate bit is less, okay, information rate, what I call it as information rate will be decrease, and width of this. So this is exactly called as two factors. All depends upon the factors, okay, exactly. This what we call it as, this kind of using of a channel bit is one of the important factor. See, this is the today technology used in AWG channel. Apart from this, what we call it as, okay, so one more, there are three factors which is influencing this communication system is multi-access communication. As I told, if channel is a bandwidth, let us say some W, if you transmit the messages, some little part of the bandwidth of this channel bandwidth, the remaining part will get unutilized. So this part of unutilized part of the bandwidth, you can utilize for transmitting this other power by other signals by other users. Such we call it as multi-access communication systems. Multi-access communication is using the channel width for a different signals of the different user simultaneously transmitting over this without interference. This is possible because of the two technological factors, as I mentioned in the previous classes, TDM, time division multiplexing, and exactly what time division multiplexing or frequency division multiplexing, for which kind is W by R. That means if I increase the band, I'm increasing the bandwidth by using a different signals, which is transmitting the signals at the same simultaneously simultaneously by using a technology TDM and FDM, frequency division multiplexing, time division multiplexing. So such we call the spread. I'm going to spread the signal across the bandwidth of the channel maybe I'm increasing the bandwidth of some signal channel up to that, because in the first case, in the second case, that is what we call as a multiple access communication, in which I'm using a different width of the width of this. So let us say W as a W, the bandwidth of the channel. Just segment of the channels, okay, in which you passes the different signal at a different rate, okay, exactly, different signal at a different rate, different signal at a different rate of that, okay, different rate, so that what will happen, will have able to pass the signal. That we call it as spread. I'm increasing the signals across the bandwidth of the channel. We call it spreading the signals across the channel. We call it as across the channel bandwidth. We call it as spread spectrum technology, for which bandwidth expansion for W is greater than 1. In a similar, one more thing is pseudo randomness. So what is exactly the pseudo randomness is, as you know that, see, look back here, as you know, the signal will be transmitted in the form of protective, what we call modulated signal. That means in digital communication, with respect to digital communication, I am sending the signal in analog form. Because look back, we have talked about so many things. Whatever the information, let me input sequence 1000, that will absolutely convert to the binary sequence absolutely in this form. These binary signals will be modulated by another carrier frequency with the kind of a modulation techniques, maybe BPSK or QPSK or FSK, whatever the case situation of that information will be protected. See, look back here, what will happen? So how, this is a very good question factor, is that how we are going to improve the bandwidth of the channel. For example, let us say single channel, single signal I wanted to transmit it. Let us say this bandwidth, okay, this bandwidth, the signal bandwidth, say W, this is less than the W1, that is W1 is going to, let us assume that bandwidth of the channel. When W is less than the W1, okay, exactly, W is less than the W1, that means unutilized bandwidth of the channel is left out. So in order to use the bandwidth, so that I can reduce the transmission power for transmitting, thus increase the bandwidth. So such for which I am going to use, in order to increase the bandwidth of the channel for a single way I'm talking about it, a single signal transmitted, what I am going to do, generate one more signal called as pseudo random pseudo noise signals, which is absolutely used, okay, a pseudo random pseudo noise signal will be utilized for increasing the bandwidth of the signal. That means whatever the signal to be transmitted, multiply to this PN signal, okay, along with this PN signal, then this, whatever the product of this will be absolutely, will be multiplied across, will be multiplied across the, will be protected in the carrier form by changing the amplitude of the carrier form, and as with respect to the product of the signal or phase and carrier of the signal with respect to this, and signals will be transmitted all across the channel. Okay, once the signal is received at the receiver, okay, exactly here, signal is received at the receiver. This receiver will consist of kind of what you call it as some noise signals. This noise signal will definitely change the signal as unexpected. It is different than expected. That due to the noises in the channel, that noise may be so many factors which I've mentioned. Whenever the signal is absolutely present, other than the signal, which we call it as pseudo randomness, it is only developed in the channel because noise, maybe three factors which I mentioned in the one factor, in the last class we are mentioning that it may be due to so many aspects, but their nature, all the three kind of noises which is present in the noises in the channel are random in nature, either at the main or mean of there or variance of the signal as per that, and hence we call it as what is the unwanted signal which present is we call pseudo randomness. So these are the factors which is keep in mind. What is spectrum technology? Using the utilization of the bandwidth, okay, efficiently, so that we can reduce the number transmitted power. Such we call it as spreader, spreading the signal to be transmitted across the bandwidth, maybe single, or instead of a single, I can send the spread so many signal in the one and spread the so many different signal along the channel so that all the signal transmit. This is also one kind of a spread system. Or otherwise, taking the single signal spectrum, single signal frequency F1 spread across the channel, we'll get back to what exactly will give the perfect. Which is called as a spectrum spread technology and pseudo random. These are the two factors keep in mind in that. So look back here. So as I mentioned, there's a model of the spread spectrum here, very important. I told you, is information channel decoder P and sequence generation. That information plus will multiply to this, and the product to where exactly the bandwidth will be increases. Then in the modulator, carrier wave generated, this product of the signal will be modulated, will be put it across to what exactly modulation signal. Then it goes to channel will be take the info, whatever the carrier contain inform of the impulse frequency response CF, then it will go to demodulator. See, demodulator is coherent deduction of the signal. How exactly? Because the here, this process here, whatever the PN sequence generated in the spread spectrum technology will be, as replica will be generated, it will be multiplied into this, and automatically the PN junction will be get over that. Only carrier frequency will be there. This carrier frequency will contain information that will be deducted of by the demodulator, then depending upon information that will go. So second channel decoder. This is exactly the model of the spread spectrum technology. Okay, so now this is exactly, please mind it, there is an interference. The interference we call it. When you use a spread spectrum technology, there is a one thing called interference. Of course, I have to mention there are a lot of factors which is contributing the signal, which is contributing on the signal to which is contributing the signal to get degraded. Maybe so many noise, external, internal factor, signal parameter, whatever it may be. When you come back to the interface, spread spectrum, one of the most important which is causing the signal in transmitted signal is signal transmitted is getting corrupted or degradation. It is due to that. Okay, so this is what exactly these noises will be have two types. One is broadband and narrowband, and the broadband signal, high broadband signals has been utilized. So such kind of a noise interferences because of the spread spectrum. See, spread spectrum technology is very important. Using the utilization, transmitting the different signal simultaneously over a single channel, or other cases you take the single channel and increase the bandwidth of the signal so that it can occupy the full channel length, absolutely with the advantage to reduce. So either one of the things, there is a kind of interference of this broadband and narrowband. Okay, so next is what exactly what you call it a direct spread. Here, what a direct spread means, you take this, see the PN, the direct sequence spread technology, you talked about it. This is absolutely the PN sequences generated at the modulator in conjunction with the PSK. That means whatever the PSK generator will spread according to the modulation PSK generated at the modulator in conjunction with modulation phases of the PSK signal pseudo randomly at a rate that is an integer multiple of a bit rate. Here very important. So R is equal to T and S. This all I explained information at T is equal to this. Now look back how exactly I mentioned it. This is the let us take the PN signal generator. It has a number of bits per cycle is more here. A number of, so this is the data to be transferred. Number of bit cycle to be told, that is the frequency, that is the bandwidth is quite less using here, as this number of bits are using, the bandwidth is quite. So now I need to increase the bandwidth of the signal. As simple as this, just multiply this V C of T and T of T. I'll get back to this equation. So that number of a cycle per second, that is number of a frequency has been increased. If it's a high frequency, a high data rate has been improved. Okay, so look back here how the things goes here. The information bit will be moved from the digital. Digital is equal to what exactly? This is the signal to be transmitted. This signal has been taken into what in a unit impulse response, or the convolution sum has been an into g prefix of t into minus ntb of this. B of t will multiply to the will multiplied by the signal from PN sequence generator. So we have C of t summation n is equal to minus into the plus infinity C of n P of t minus t PN sequence. Cn is equal to binary PN port sequence plus or minus P of t. So V of t into C of t. Okay, exactly. V of t into C of t's multiplication goes. This is absolutely spread across. Is a very clear look back. You can see this. This is the spectrum of the signal to be transmitted. Okay, spectrum of the signal to be transmitted. This is the absolute. This is the spectrum of the signal. And here, what exactly here? This is the PN junction generated. Okay, C of t, and this will be multiplied across. We'll get back to this. Look back, V of t is equal to AC, V of t into C of t into cos 2 pi CT. Okay, exactly, cos 2 pi C. Okay, exactly, cos 2 pi C. Okay, this when you multiply this two factor, the bandwidth has been 1 by TB plus 1 by T, it will be get increased. So look back here, this is the modulation signal which it's sending across. I mentioned it. Okay, exactly. Here what will happen? See, look back here, what is the situation now? See, phase theta 2 pi ct plus theta. See, when theta, when magnitude is 1 of the product, that is this equation, the magnitude is 1 when there is a theta is equal to what? Absolutely is 0. That is why we are showing that theta of phase of the carrier wave, this is theta is equal to 0, v of t is equal to 1, theta of t pi is equal to v of t minus. Therefore the transmitted signal is a binary signal in binary form. Okay, exactly. See, look back, I mentioned it in the classes, the rectangular pulses of this. Okay, rectangular pulses, absolute, the each rectangular pulse, the generated frequency we call it as chip bit rate. So L is equal to what? TB by TC. This is the one we call it as, we are going to trade off with this aspect, which I already told in the last classes. Okay, exactly. So this is exactly demodulation. How exactly the demodulation goes? Okay, exactly, the demodulation process. This is what we're talking about. This demodulation is the one which has to be two very important. Keep in mind, remove the PN junction and retrieve the information. Two things are very quite important. Removing the PN junction, we call it as a PN junction, PN dispreading process. How the dispreading process, received signal is here. There is absolutely V of t into C of t into what I mean, V of t into C of t into cos omega of ct. It will multiply into the what? C of t, ct square. So this means, and what you call same signal will be generated here. So C of t into C of t square. This becomes, I mentioned it, that magnitude of the PN signal is equal to 1. We get back to this, what you call it as this process. That means this process we call it as undue, what you call undoing the spreading process, we call it as despreading process, also called as. Okay, so despreading process is AC into omega V of t into cos 2 pi ct. Okay, exactly. So this is what the real effect of spreading on narrow band interferences. Okay, exactly. So there is a kind of interferences, as I mentioned, I of t is equal to, there is an information, what I call it as a noise. This noise will have AI into cos, that let us assume is a sinusoidal input I of t. Substitute this, assuming that interference is the sinusoidal thing, just substitute back, and as per this is multiplied into the what? C of t, because in the process it goes to multi I of t into C of t. Okay, exactly. We are able to get it of this, what you call it as I naught is equal to, what you call it, I naught. Okay, exactly. Okay, I naught is equal to I naught is equal to power spectral density, Pa is equal to interference power. When you just calculate, these are the simple equation which is power they are given, P is equal to IR, all these things. So we are able to find it is equal to PW by R. Okay, exactly. So these are the factors, and these are the factor, and there's a probability of error is equation is absolutely clear. Probability of error is identification, detecting the informations. Now let us say what is exactly the simple, there is a called some application of a d spread spectrum, these things. Okay, low detectability signals. So there are one kind of this one information. So let me talk about low detectable signal. Here what will happen, whatever the transmitted messages across the, maybe it is exactly increasing the bandwidth or increasing the transmission rate or increasing that. Okay, exactly. All right, which will okay, which will be this increase in the bandwidth, this will have a low power as relatively compared to channel width. So when you say whatever the transmitted signal which has been utilized the bandwidth in spread spectrum technology, which has a low power, when you relate compare the power of the channel which is provided of the channel noises, maybe interferences, which we call as a low detectability signals. So generally the PN is equal to the power of the noise in the channel, PR is equal to what exactly, less the power of the received signal. So in order to detect the signal at the receiver, maybe coherent detection, PN by PR should be less than 1. Okay, so then the second is what exactly, the first second publication today, this the spreading process is absolutely talks about it. The code division of the multiple axis, we call it as a CDMA. What exactly the CDMA? Please mind it, very basic principle of the our spreading technology, basic principle of communication systems here exactly is what we call it as a spread spectrum. That means there are two cases that I have mentioned it very clearly right from the starting of this unit, that is this modulo. Using the bandwidth, that means sending the information at a different time, at a simultaneously, over the same channel width. That is also one part of spectrum technology. So what is exactly code division multiple access? Here the information is a code. Each codes will be transmitted with some frequency of the some part which is occupied some part of the bandwidth of the channel. That is we call it as code division multiple access. Very important, please mind it. The code division, the information is a coded, that is why we call code. And division, each code will be occupy some part, some division of the bandwidth of the signal. That is why we call it the division. And we multiple these, each code will be utilized by a different user with a different frequency which is confined within the bandwidth, and we call it as multiple axis. We call it as code division multiplier. These are very simple. See, this I explained it. Very large number of users can be utilized in a short period. The second example in a deep spreading, that is spectrum technology, what we call it as communication over a channel in a multi paths. See the multiple propagation in the reflected delay. Okay, so next is what exactly wireless communication. See, look back in the wireless communication. Let us take simple a LAN, local area network of the high standard IEEE 802.0111, the 802.11b, which is exactly has 2.5 gigahertz in ISM. ISM band means industrial, scientific, and medical. These are the bandwidth of the available bandwidth utilized by this media. That is exactly industrial, scientific, and medical ISM band. LAN standard is 802.11, 802.ab. Available bandwidth is divided into 2.4 gigahertz ISM. The requires, so look back, this sequence is modelized either BPSK or QPSK. Okay, exactly. So this is absolutely the multiple propagation due to reflection from the channels. Okay, communication over a channel with multiple path, wireless. Okay, exactly. Okay, exactly. So now another important point is that what we call it as conversion of the PN junction, PN sequences. Okay, see PN sequence, I told you that what is exactly the PN sequence, very important. With the very first block itself of the what we call it as a digital block diagram of the digital communication system, I mentioned it. Whatever the signal comes, let us say information signal, whose bandwidth will be increased so that it will occupy the bandwidth of the, like the full bandwidth of the channel as per the bandwidth expansion factor B is equal to W naught to get some kind of an advantage, maybe less transmitted power by using bypassing the less transmitted bits. So this is the one of the factor here exactly. So bandwidth. So this PN sequence will be generated as soon as the signal comes in binary sequence signals. Then this will be multiplied into the PN sequence, which is in the form of the coded 1001. Okay, this information will be multiplied into the what, the information which enhances the bandwidth of the signal. Then this signal will be transmitted over the channel with the help of the what exactly modulation techniques, either BPSK or QPSK or FESKs, and the signal will be transmitted to the reservoir. And similarly, I mentioned it very clearly, the same kind of replica of PN, same kind of a replica, okay, same kind of a replica signal, this replica PN sequences C of T will be utilized, will be used in the receiver, and this signal will be used for what exactly we will call as a deep spreading process. Now, how this sequence? So that means the PN sequence at the transmitter, PN sequence at the receiver. The PN sequence at the transmitter will help you to spread the bandwidth of the signal to be transmitted, where exactly PN sequence at the receiver will help you to will de-spread the process, exactly de-spread the signal to be processed. Exactly, this is okay. So this is what so how it works. This is what the help of the PN sequence. Okay, so that means how exactly it goes here, how the PN generally PN sequence has to be 1 and 0. It generates the sequence of 1 and 0. It maps the what we call it, maps the coded PN sequence into the signal to be transmitted in such a way that bandwidth of the signal will get enhanced. For example, let me say there are some things, there are a kind is, let us take 100. This is the information code to be transmitted, but it mapped to 1 comma minus 1. Let us assume that means bandwidth of that will be increased. So this mapping of the data will be takes place. Let us not talk about too much because it's quite a very very technological factor issue. As we are at the graduate level, let us assume that at the stage, the PN junction generates the binary sequence of a daughters. These daughters will be mapped into the other kind of a binary sequence, 1, 1, 1 minus 1, that is generated by sequence sequences. So in order to increase the bandwidth of these signals, so that it will occupy the full channel bandwidth. Okay, so how exactly this bandwidth will be generated? That is PN sequence, that code of functions here. As simple as this is simply here, look back here, it is a shift register length. This is a shift register length. Okay, it will contain number of bits. Let us say m is m and m minus 1. What will happen? Initially it recorded some of the parted. Okay, just it will be coded 1000 some of the coded like this. Okay, what will happen? For each bit will goes to sum. Okay, so then it goes to the linear. Each bit will be just shifted by a factor towards the left one. Okay, as it shift, same bit will be transmitted, same bit will also go. So likewise, the sequence of the PN sequence will be generated. Look back here, the PN sequences is equal to maximum length of the shift register sequence. Shift register length is equal to comma 2 is equal to 2 minus 1, generated by a shift register and non-linear feedback. Okay, exactly. The generated sequence is a periodic with each period. Okay, in DS spread application. Okay, this is absolutely I mentioned. See how exactly the basically the PN sequence is the sequence of 0 and 1s. These sequences will be coded, will be mapped sequence. This will be mapped into the information to be transmitted in order to enhance the bandwidth or in order to decrease the bandwidth, whatever the cases, depending upon our specific application, to get kind of an advantage. What we mentioned in terms of the bandwidth or a transmitted power, that is R and W. Okay, so now if you say the PN sequence is a short with the sequence of 1 and 0s, how exactly the sequence will be generated? As simple as that here, the sequence of 1 and 0s will be absolutely coded in the shift registers 1 0 0 0 0 0 0 0 1 1. Okay, what we call a shift register. So at one the initial bit will absolutely goes back here. The each will be go back, will be summed together, and it goes to what exactly each summation of the bit goes, and it started to shifting one. That means at the output some sequence will be generated. Right now please understand how the sequence, how the mapping, it's quite difficult. Of course it has been mentioned in your chapter, it is required as per syllabus. So just for a momentary purpose they have given, it will be there in the notes. You can see it also. I'll just explain it as of now. So this information will be generated by shift register methods. Okay, so now one important method is very clear. Each bit sequence generated should be a periodic. For example, first it generate 1 0, next it generate 1 0, or next it may be 0 1. So each bit, that is 1 0 or 0 1, will be what should be a periodic in nature, so that this goes. Okay, so this is one of the very important. Generally, that method what we have mentioned, by using shift register, we are going to generate the PN sequence, is not in very much periodic. So very much periodic has been very most important sequences that absolutely which absolutely required. Okay, which is absolutely periodic between the sequence generated. So in order to enhance the periodicity between the different PN sequence generated, there is one more method has been developed called as a gold. Okay, see here one of the sequences has been generated. This sequence will be this another pair of a sequence will summation together. So the absolute periodic will be generated. Okay, so right now just understand the fact that is PN sequences will be 1 0 0. Okay, like. So this is what the PN sequence. A last part of our syllabus of the Modulo-5 is what we call as frequency of spread spectrum. Please kindly, as I mentioned it very clearly, in the spectrum technology, whatever the receiving signal, the information signal will be multiplied to the PN sequence in order to enhance the bandwidth or in order to enhance the bit rate, depending upon what the requirement applications. So after the signal, then once the PN sequence is multiplied to the information, the resulted signal will be protected in the form of the carrier wave. How exactly? Take one of the carrier wave, let us say AC into cos omega, set the carrier sinusoidal wave, whose amplitude or a phase or a frequency will be varying in accordance to the product signal, which will be sent across to the channel, let us say AW channel, to the receiver. So what we talked about in the last, that is D-spread, is exactly called as PSK modulation techniques. That means once it get multiplication in the direct spreading, the amplitude of this will be vary. Amplitude of the carrier wave will be varied in accordance to the product of the signal. In the frequency, if you use the FSK, that is frequency shifting pattern, the frequency of the signal of the carrier wave will be changed in accordance to the product of the signals. So that means the frequency has to be changed from one point to the one point. Look back in frequency. It's very important point is here. Please mind it. We are using the channel efficiently. We are using the channel efficiently. Bandwidth. That means it occupies the different parts of the bandwidth with the different frequencies. That means each one. Let us say in spectrum value in the multiple axes of this whole bandwidth will be divided into B1, B2, B3, B4 part of each bandwidth will have some kind of a frequency. Each bandwidth will be used by the different user in order to transmit their signal. That is a frequency. Okay, exactly. That is kind of each multiple access user will be sent across to their allotted bandwidth of the product division of the bandwidth of the channel. So that will go. That means frequency will off depending upon the signals will go at the end of the what you call as frequency spread this. Okay, exactly. So now how exactly goes here? Very simple here. That kind of a things we utilize for FSK modulation tactics. Okay, that means once this gets by the PN sequences, then the different frequency will be utilized. Then it will be transported in the same manner. Despreading takes place at the receiver point of view and generate. So that is exactly here the channel information will be coded. Okay, exactly the channel information. This will be goes to the what FSK frequency shift modulators. Okay, exactly. That means what will happen here frequency shift modulator. So look back here. This is the information. The frequency modulator, it modulates the information signal, which will be multiplied. This will be multiplied the PNC sequencer. This PNC sequence generator will select the carrier frequency in order according with this and multiplied across to the mixer. Then the signal will be generated. That means here what will happen? The frequency synthesis. This is PN sequence. Okay, this PN sequence. Okay, exactly. This PN sequence will be generated code of 1. It will be select FC, the frequency. This frequency will be mapped into the FSK modulator and sent across the channel, and we'll have the same kind of exactly. This is receiver part. This is exactly what transmitter part of that. Okay, so you look back in and this is what is exactly the frequency of split signal or split spectrum. Here in this kind of a modulation table, frequency shifting modulation has been utilized. Okay, so the frequency modulation has been utilized here. This is the information will be coded across the what exactly the FSK modulator. Okay, FSK will modulate the information. Okay, exactly. Here there's a PN sequence generator. This PN sequence generator will select the process FC. This will goes and this will be mixed. So that means we are using the frequencies. That means that is why in these cases we are used of the frequency shift frequency shift modulation techniques. And this signal will be transmitted over the channel. Okay, exactly. This is the transmitter. This is exactly the receiver. This is exactly the receiver part of that. Okay. So encoding, this is encoder, decoder, FSK. Okay, exactly here. The encoder is decoding FSK modulation, select. Okay, exactly. So look back here, all I explained, it's very simple. This is, you can see how the frequency hopping will be takes place. This is the simple hopping. This is one frequency for first period, maybe one signal is going. The second period, second signal is going. Third time period will go. So DC, the first 2 CT, 3 DC, a different kind of a signals has been passed in the division of the bandwidth at will be goes. This is all depend what kind of a frequency. Look back here, very simple. It will be generated by this. Okay, we coded in the information at the design product. This is exactly the frequency of the information. You can see okay, that will be covered up. So that's completion of the fifth module. To understand, we can repeat the we can see the videos. Okay, bye. Thank you.